Welcome to the Real Python Podcast. This is episode 198. Can you build a Space Invaders clone using Python's built-in turtle module? What advantages does the Seaborn data visualization library provide compared to Matplotlib? Christopher Trudeau is back on the show this week, along with special guest Real Python core team member Bartosz Zaczyński. And we're sharing another batch of PyCoders Weekly articles and projects. Bartosz shares a Real Python step-by-step project for building a video game using the Python turtle module. The turtle module provides an interactive environment that lets users create pictures and shapes on a virtual canvas. And this project uses the module to take you through game design concepts, such as animating sprites, detecting a collision, and building a game loop. We discussed another Real Python resource, visualizing data in Python with Seaborn. Seaborn is a significant next step if you've already been working with Matplotlib. It produces impressive visualizations and offers a functional or object-based approach to designing plots. We also share several other articles and projects from the Python community, including a news roundup, finding Python Easter eggs, exploring whether Python has pointers, styling Excel cells with OpenPyXL, using weird tests to capture tacit knowledge, inspecting and running Django Commands in a TUI, building Reactive Web UIs in Python, and a project for predictable Python datetimes. This episode is brought to you by Posit Connect. Posit is dedicated to open source data science tools, and Connect helps teams manage all their data science publishing. Learn more at pos.it/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back to the show.
Hey there.
So we have an additional guest this week. We have Bartosz from Real Python. He's one of our core team members, and I wanted to welcome you to the show.
Thank you for having me. It's an honor to finally come to your show, Chris.
It's great to have you on here, and we got some fun topics to dig into this week. A code conversation. We haven't had a code conversation in a while, so that's going to be fun to discuss. And of course, we got our news. So, Chris, do you want to start off the news?
Sure. Couple quick release announcements. It's another week, therefore Alpha 5 has come out. This announcement is like listening to a test version of those picture puzzles where you try to see what's different. On the left side, we have a 4. On the right side, we have a 5. One of the more exciting things in this release is the branch containing the code that disables the GIL got merged in. So this is a command line switch and is part of the continued work of the GILectomy. It's a big time, long time, big milestone things coming. So,
yeah, we have a link for people if they're interested in digging into that, the actual pull request, allowing the disabling with some notes there, right?
Yes, we do. In fact, I can tell you that the PSF's not so great about the alpha release notes. It's sort of a general release note, and the release note for 4 looks the same as 5. And so I actually had to dig into commit tags to figure out whether or not the GIL commit had actually made it in, but it's there. It's there along with dozens and dozens of other commits. It's kind of impressive how much happens even in the few weeks between Alpha 4 and Alpha 5. There's a lot of good work going on there.
Great.
Second one is a quick security fix release for Django with a potential denial of service attack in the truncator routine. Patches are 5.03, 4.2.11, and 3.2.25. So if you're on Django, go grab an update. And then the final announcement is Stephen Gruppetta's new book called The Python Coding Book is out. Stephen is a Real Python contributor. In fact, I think we're highlighting one of his things this week by complete coincidence.
Yeah.
But the book is for beginners. So if you've found our show because you're just starting out, or if you know someone who's getting into coding, this is a great choice. He's got a very comfortable, easy, approachable style. Right now, the ebook is out, and the Dead Tree version will be available in Amazon shortly.
Awesome. So that gets us into our main topics today. And we were going to start with a code conversation that Bartosz is hosting. And what I thought we could do just briefly is we featured a bunch of your tutorials and step-by-step projects over the years here at the podcast. But I wanted to maybe just talk a little background stuff. Like, how long have you been at Real Python, Bartosz?
Oh, that's a good question. That must be years now. I joined Real Python as an internal content creator in July of 2020.
Okay.
But prior to that, I wrote a few tutorials as a freelancer while I was still primarily working as a software engineer.
Yeah.
And at that time, I already had some experience teaching Python at a coding bootcamp. And I also had just published my Python video course.
Nice. So what are the types of articles you like to focus on?
I like to focus on those deep dives where I get to really spend a lot of time going deep on some technical stuff. I like covering media stuff like music, 3D graphics, or some binary data munging and wrangling.
Yeah. We featured your maze tutorial. That was really fun and interesting.
Oh, thank you.
And then you have a upcoming audio one. I don't know if I want to spoil it, but that one sounds very interesting because you know how much I'm into audio.
Exactly. And I have another audio related tutorial coming up on my queue. So that one is going to be even more exciting, I think.
Oh, cool. Great. So this course, whose idea was it for this particular code conversation?
Right. So this comes quite timely because it's a conversation about Easter eggs in Python, which our colleague Philip and I have recorded. It's a bit of a long story, which started last year after I finished writing a short guide about the Zen of Python. We always try to supplement the tutorials with some bonus materials that real Python readers can download. And these are typically code examples in the form of Python files or Jupyter notebooks or cheat sheets and other resources.
Yeah.
But I was really struggling with an idea for this particular tutorial, which was quite unusual since it was almost completely non-technical. Instead, it explores the history of the Zen of Python and some of the inside jokes around it, but there was virtually no code or anything of that sort to show. Fortunately, Kate, who was our editor at the time, came to the rescue and had this clever idea to make an interactive Python Easter egg hunt game that would give the readers clues so they could, discover those Easter eggs on their own. And the game turned out quite nicely, so I would highly recommend our listeners to give it a shot. They can download a PDF from the Zen of Python tutorial or the code conversation video that I'm going to talk about. So shortly after we published that Zen of Python tutorial, our friend Philip, who's also an active member of the Real Python team, reached out to me asking if I'd be up for recording a conversation with him about the Easter eggs in Python. Internally, we have this video course format called the Code Conversation, or codenamed Coco, where the participants talk about a particular Python programming topic.
Yep.
And again, this one wasn't very technical, so the result turned out to be more like a podcast episode rather than a live coding session.
It definitely starts that way, yeah.
Yeah, normally there are hands-on code examples, and it resembles a live coding session, essentially. Anyway, we first explained the very concept of Easter eggs and the Easter egg hunt game in popular culture, which was something new to me. I mean, even though I've always celebrated Easter, I somehow have never heard of the game. And Philip explained to me that on Easter Sunday, his parents would hide Easter eggs in the garden while he, along with other kids, were waiting. And then they would all go outside with little baskets trying to find and collect those hidden Easter eggs. And apparently some of these eggs were made of chocolate, making them a bit more interesting than the usual, boiled eggs.
So that you wouldn't have anything like that?
No, never. Actually, when I asked my wife about it, she was like, yeah, sure, I know the game, but not from experience. It was from the movies,
Oh, yeah.
So it wasn't part of our culture, at least.
Yeah, we were definitely a big plastic egg with on the low end, it'd be like, ooh, there's a penny in here. on the high end, it'd be like jelly beans or definitely chocolates and things. Yeah,
Mm-hmm.
Chris?
Yeah, my mom used to do it for her grandkids, and it was the plastic eggs with like little messages in them, so that if they, in case they didn't miss one, you didn't want to accidentally find chocolate 6 months later underneath the couch. So that this was a slightly safer version. Yes.
So the term Easter egg has obviously crossed over to other areas of culture and is now often used to describe hidden features or messages in various forms of art like music, movies, and probably most commonly video games. And I'm sure you've heard of at least a few. In the car industry, Jeep is perhaps the most famous for hiding Easter eggs in their vehicles. I'm not sure if you've heard of those.
I think so. You might have to refresh me.
So some of their models feature this silhouette of the original 1941 Willys Jeep on the windshield, which looks as if the car was climbing up the edge. And I think it's kind of a nod to the off-road legacy of their cars. They also put some strange animals like geckos and spiders or even flip-flops in weird places in the car.
Yeah.
Anyway, in our conversation, Philip and I focus on Easter eggs in software, and particularly Python, and their history, why people started putting them in the first place. And there's actually an interesting and pretty reasonable story behind it that I will not spoil now.
Yeah.
We also share some popular Easter egg examples outside of Python. For instance, if you're using a Chrome-based web browser and you don't have internet access, it will display this cute T-Rex dinosaur. But if you hit the spacebar on your keyboard, it will actually turn the dinosaur into a platformer game, so you can entertain yourself while waiting for your internet connection to come back.
Yeah, that's one I didn't know, and it was actually kind of a fun surprise for me. I was going to mention, you talked briefly about the idea of Easter eggs being in other parts of culture. Like, I was in one of those 90s bands who decided to have a hidden track on the CD.
So that was the first part of our conversation with Philip. And in the second part, we go through a few Easter eggs in Python, which there is no shortage of. We'll probably find more in the future as they can remain dormant for literally years until someone stumbles upon them.
Yeah.
And it's also interesting to learn about the lengths to which the CPython developers go to hide their Easter eggs, making sure, they're not obvious and you can't just find them by looking at the code or the documentation. So I don't want to spoil too much at this point. Let me just say that the core Python developers have a lot of sense of humor, inspired by the Monty Python group, which is evident when you think about the naming of the language itself.
Yeah, even the initial one for the XenoPython, I think is a great one that I think a lot of people might not be aware of, that is an Easter egg itself. So I'll let people check out your article if they're not familiar with that. And I have a link to not only the video course, the code conversation, but also your original XenoPython one, which, again, I think would get people in the mood before the course. Posit, makers of Shiny and Quarto, and formerly called RStudio, is the public benefit corporation dedicated to making great open source tools for data science. Let me ask you a question. Are you building awesome things? Of course you are. You're a developer or data scientist. That's what we do. And you need to check out Posit Connect. Whether you're building with Streamlit, Shiny, FastAPI, Dash, or Quarto, make deployment the easiest step in your analytics workflows. And ease your IT team's workloads with Posit Connect. You can try Posit Connect for free for 3 months by going to pos.it/realpython. So my first one is a Real Python tutorial, and this one is by somebody I featured a couple weeks ago, Ian Eyre. We featured a recent article about using Python for data analysis, and Ian Eyre has taken his data science chops a little bit further here in this next one. It's titled Visualizing Data in Python with Seaborn. I really like the approach for this tutorial. It's a good starting place. If you haven't done really any visualizations, it's a good way to get you going on it, which I think is always nice to have an introductory course where they're not assuming a lot of stuff about it. Also, I think if there's anyone who's been using Matplotlib, you may really enjoy the way that Seaborn sort of builds on top of how Matplotlib not only thinks but works. There's sort of two primary ways to approach building data plots with it. The first is what they term a functional interface. And I really like that one. You can kind of very quickly get going with it. It actually uses less code. It can make a lot of assumptions about things. If you've imported, you have a data frame in memory, it already knows lots of things and will extract names for you and do stuff like that. The only additional things you might be doing is if you really want it formatted nicely, you can make sure that this is capitalized by setting the title specifically or adding tips and things like that on top of it. That functional approach, I think, is really great. It's very quick. It seems like that was maybe the first approach that Seaborn had. And then as they continue to work with the library, they have an entirely different approach if you're interested. And that is an objects interface. And that one is much more piecemeal. You can build your plot and all the separate components up from scratch if you want and get very, very detailed. And so in some ways, the functional one lets you very quickly get going. This one will let you, if you have a very specific way that you want to present your data and you have something in mind, this one will be much more in that vein. We featured a few other data visualization libraries on here. We featured one, I think, called Plot9, which uses this grammar of graphics, which was introduced in ggplot2. But Plot9 used that. I think I've featured that a couple times on the show to talk about it, and also as a video course spotlight in the past. And in that, you're going through and thinking about layers of your stuff. You got your data, and then you're thinking about the individual points that are on there, the markers, and then you're kind of, again, building on top of that. And Seaborn's not only a great library to work with, but it's very pretty, which is another thing that builds on top of Matplotlib. I like the examples that were given here. There's Python code for all of them, along with the graphics of like what you should be outputting when you're done, what the plots look like. He also has some of those kind of hidden exercises, which I mentioned before that Ian had done in his previous tutorial that we had featured. And those are with that nice kind of collapsible show hide hidden sections. You can look at the exercise and then also then open up the solution later if you want. He shares some things about grabbing data from Kaggle, and you use that to do a plot about serials. You're exploring everything from histograms to line plots to box plots with the additional error bars. So it's a real exploration in a pretty long and detailed thing. Again, I think this is one that you could approach across multiple days as you kind of dig into this and try out all the different examples. So it's a deep dive into Seaborn. I want to thank Ian for sharing this tutorial with us. And I think, again, anybody getting into data science will get a lot out of it. I know that you were part of the editing team on this one, Bartosz. Do you have any thoughts on this?
That's right. I was the technical reviewer for Ian.
Okay.
And this was the first tutorial that I reviewed for Ian. And it was really great. I mean, what I liked the most were the exercises that you mentioned. That's something that shows Ian's background. He's a university professor, if I recall correctly. It really shows throughout the tutorial. He thinks about the end user of the tutorial, which is someone who wants to really learn some new skills.
Yeah, I think that's a great approach across it. And I definitely can feel that. So I'm looking forward to seeing what Ian's working on next. So Christopher, what's your first one?
I've got an article from Ned Batchelder, who we highlighted back in episode 132, talking about his decorator article. This time around, his post is called, "Does Python Have Pointers?" Ned's a bit of a gray beard. He actually has a beard with gray in it, so it's literal in this case. So his answer is a little more nuanced than the usual one. Instead of a simple yes or no, Ned says it depends. The reason it depends is due to the fact that terminology in programming is often looser than we realize. We like to think of it being, very specific, but often one language will call something similar to a concept in another language, but they're subtly different. So let's talk about a language like C and what a pointer means in that. And that kind of helps us define the question. So C is barely above machine code, and in it you have direct access to memory space. When you create a variable in C, you can ask where in memory it is stored. If you store the address of something in a variable, that new address variable is called a pointer. It points to where something is stored. You can do interesting things with pointers like math. So let's say you've got an array of values that start at an address of 1000. You can get at the 10th item by adding 10 to the address and accessing that spot. It's not quite that simple, as that only works if everything in the array has a size of a single byte, but you get the general idea. Once you've got a pointer, you can dereference it, which is a fancy way of saying using it backwards. You can say what value is at the spot that this pointer points to. So when I get that 10th item, I'm actually taking the address 1010, but I can also ask what is stored there. I'm pretty sure I've got a off by one error inside of my example, but that's fine. You get the idea. And if this is the first time you've seen a one off by error, then welcome to programming. Anyways, many languages have this identical concept, including things like C++, C#, Go, Rust, Pascal, and even way back to Fortran. So strictly speaking, Python does not have this concept. In CPython, I can ask for some internal information about where an object has been stored by using the ID function, which is pointer-esque, but there's no way of saying, give me the thing at a certain value. There's no dereferencing equivalent. This is what makes people say Python doesn't have pointers. So why did Ned say it depends? Well, everything in Python is an object. And your variables are actually references to that object. So Python doesn't have explicit pointers, but you could argue that every variable in Python is an implicit pointer. Ned then references an older post of his called Same Words, Different Meanings that touches on the problem in programming where two languages might use the same word to mean subtly different things. Add in a bit of a flavor of the internet where pointless arguments rule, and you can get into conversations about whether or not you can call dunder init a constructor.
Yay.
Ned's always good for learning things and a bit more of a nuanced approach than your average internet post. I blame the gray in his beard.
So that's it's nice that it builds on top of 2 weeks ago, we had an article from Stephen Gruppetta actually about names in Python, and it's kind of slightly related in that sense. And I think I featured a video course talking about pointers, a real Python resource there if you're interested in digging a little bit more. So speaking of Stephen Gruppetta, Bartosz, you have something brand new from him.
That is right. So I have a fascinating tutorial to share, which combines a couple of interesting ideas in a really fun way. The tutorial is entitled Build a Python Turtle Game, followed by a subtitle, Space Invaders Clone, which may already give you an idea of what I'm going to talk about. It is written by Stephen Gruppetta, mentioned by Chris already, who's our external author and who recently started writing more tutorials for Real Python again. I was actually Stephen's first reviewer on Real Python back in 2020, which feels almost like yesterday. Stephen is a busy content creator and educator outside of Real Python, and I will just reiterate what Christopher has said, that Stephen has just published a new programming book for Python beginners, which was probably one of the major factors that kept him occupied. Anyway, he's now back with a new tutorial. It's one of those that we internally like to call step-by-step projects, which essentially take the reader from nothing to a fully working project at the end, simply by following small steps. And the idea behind these tutorials is similar to building like a Lego set based on step-by-step instructions. So there's very little theory and maximum emphasis on practical outcomes in those project-based tutorials. What's nice about them is that each step has a corresponding snapshot in the bonus materials, which you can download. So even if you're stuck at any point, you can always compare your code against the provided example and move on. In this case, the goal of the tutorial is to build a fun game based on the classic Space Invaders, which probably needs no introduction. It's one of the earliest shooter video games, first released almost half a century ago. And like many other popular arcade games from that era, Space Invaders was developed in Japan. The game features a laser cannon, which is placed at the bottom of the screen, which the player can control by moving horizontally, either to the left or to the right, and by shooting the enemies. And as the name of the game implies, your enemies are aliens invading Earth from space. In the original game, the aliens were arranged in a few rows and moved toward the player from top to bottom, while also shooting at the player. The game would end as soon as one of the aliens reached the bottom of the screen, unless the player successfully eliminated all of the enemies. And there were a few additional features in the original game, like special enemy types or the variable speed of the enemy approach. But these are not covered in the tutorial, which just builds a simplified version of Space Invaders. So when you finish the tutorial, the complete source code for the game will be less than 200 lines of code, and that includes comments. And the best part about it is that it doesn't require any third-party dependencies. It just runs using plain Python. And to be more exact, the game relies on the standard library turtle module, which implements the so-called turtle graphics. It is a concept borrowed from the Logo programming language, which I vaguely remember from school. Has any of you heard of Logo before?
Yeah, that was one of the few things that was taught in school for me. I think it was on Apple. I think they were the Apple II. They were.
I was about to say, yes. Speaking of rolling my eyes at this game is almost 50 years old. That was Apple IIe with the turtle Logo programming language. Yes.
Yeah. Luckily, we were able to do some other programming and write from magazines in our free time in the labs. But yeah, Logo was something that was covered in class from time to time.
Cool. Well, so Logo was an educational programming language. It was, like you said, designed in the 60s. And the goal was to teach programming concept through drawing, which popularized turtle graphics. So what is turtle graphics about? It is a way to draw vector graphics by means of controlling a virtual cursor, which is often depicted as a turtle, and letting it draw lines on the screen as the turtle moves. This turtle has a location expressed in two-dimensional coordinates and an orientation or a heading angle. And it also has a pen. The pen itself can be on or off at any given moment, and it may have additional attributes like color or line width. And now by telling the turtle to rotate by a certain degree and move forward by a specified distance, or just go to the specified coordinates directly, you can draw lines, curves, and even complex two-dimensional shapes. And I just learned there was a company that sold an actual physical turtle robot, which you could put on a piece of paper on the floor, and it would literally draw the shapes you program into it, which I think was cool.
It had a pen up and down with colors too? Or?
Yeah.
Wow, okay, yeah. That's cool.
Yeah, well, obviously today we all have screens and printers, so that's not an issue anymore. And in Python, we have a turtle module, which does all that. By the way, if our listeners are interested in learning more about the turtle module in Python, then we do have a beginner's guide to turtle on real Python that we can link to below. At the same time, by no means is it necessary to be able to follow along with Steven's tutorial, as he does a truly fantastic job breaking things down and hand-holding the reader throughout each step. But back to the tutorial itself. So it has 9 steps in total, but you'll end up with a working game as early as step 6. The remaining 30% are about implementing nice-to-have features like adding a game timer and score, controlling the player's movement in maybe slightly smoother manner, or ensuring a consistent frame rate so that the game will run at the same pace, regardless of how fast your computer actually is. Along the way, the tutorial teaches you about some fundamental game development concepts. For example, besides the frame rate that I just mentioned, you get introduced to the game loop, which is the core control flow mechanism in your game. It is the driving force behind the game that continuously handles user input, updates the game state, and renders the view until some condition is met, indicating that the game is either over or the player has stopped the game. In some sense, the game loop is similar to the event loop in asynchronous programming. So if you've done some JavaScript programming or used the async await keywords in Python, then it should feel familiar. Another huge topic in game development that you'll learn about from the tutorial is collision detection. It can tell you whether 2 or more sprites, that's the visual elements that make up the game, have collided. For example, it's quite useful to know if you've hit an alien with your laser, or if one of the enemies has reached the bottom of the screen, effectively ending the game. And apart from these game development concepts, you also get exposed to some common gotchas in general purpose programming and ways to cope with them. So even if you're not specifically into game development, there's something to gain from that tutorial. One example would be looping over a collection, which changes its size during iteration, which can be a surprising thing until you stumble upon it for the first time in the wild. Finally, at the end of the tutorial, Steven shares a few ideas for making the game more challenging when you get good at it. All in all, I can guarantee you'll have a lot of fun going through this tutorial, even if you're just a Python beginner. So highly recommended.
So I'm curious, does he use the turtle functionality to redraw every frame, or is there a sprite concept inside of the turtle module?
So he briefly mentions sprites, but I don't think he actually explains thoroughly, what a sprite is. He just implicitly assumes, okay, a sprite is just a visual element. It could be a player, an enemy, or something like the laser beam that you're shooting at someone. but he doesn't use any built-in functionality in the turtle module to leverage sprites per se. Every frame is just rendered using simple graphics.
Really? Wow. I'm surprised it can go that fast that you can get the animation. Yeah. Holy cow.
Yeah, I know. That's what I was thinking. Is like the speed of it. Yeah. He is a huge fan of this library. He is a huge fan of using it to teach things.
Yeah, I've seen a lot of articles from him. Yeah.
Yeah. So I think it's interesting, and I think it's a great way to get people into programming. And so I don't know if this would be my first stop. I don't know how. What level would you consider this at? Would you think somebody would need to know a little bit about Turtle, or could they just jump right into this?
They can just jump right into this. It's targeted at beginners.
Okay, good.
And we have a separate tutorial which goes deeper into Turtle itself, but it's a step-by-step project, so it glosses over some of the, technical aspects. It just focuses on building a fun game.
Yeah. That's great. I'm looking forward to checking it out. This week, I want to shine a spotlight on another Real Python video course. It's titled Python Turtle for Beginners. The course is based on a Real Python article by Nikita Silaperasetti. It's designed for students and Python beginners. And the course is here to help you on your journey as you take your first steps into the world of programming. In the video course, instructor Darren Jones helps you to understand what the Python Turtle library is. You'll learn how to set up Turtle on your computer, and you'll start creating your first Python programs using the Turtle library. Along the way, you'll grasp some important Python concepts along with the Turtle commands, and develop a short but entertaining game using what you've learned. If you're a beginner to Python, or you'd like to introduce other people to the language, then this course will definitely help you on your journey, taking your first steps into the world of programming. The video course is broken into easily consumable sections and has code samples for the techniques shown. Like all of our courses, it has a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. My second one is from former guest Mike Driscoll. He's been on the show a few times. He was on to talk about PDFs and also about the Pillow library, both things he's written books about. Mike provides a new tutorial called Styling Excel Cells with OpenPyXL, which is OpenPyXL and Python. It's a library that we've done some different things on Real Python about, but it's a very popular tool for manipulating Excel and working with Excel documents and so forth. So this one is really about styling and making stuff look nice and enhancing your Excel spreadsheets. He focuses on 4 different sort of components of style. The first being fonts. He starts by sharing basically all the different parameters that you might be interested in. You can get into individual styles of cells, but you can also look at rows and columns. You specify Excel, when you look at what they call a workbook, is multiple sheets. So you have to specify, first off, the sheet that the thing's on, and then the individual cells that you want to adjust using the typical Excel battleship style notation to choose where that stuff is. So A1, B2, those kinds of things. So he goes through that. You practice changing the fonts in a few cells, choosing everything from bold, italics, color, those kinds of things. The next 2 sections talk about setting alignment, practicing left, right, center, choosing things to be vertical or not, all those kinds of different styling things you might be interested in as far as alignment. And then the next big area is about borders and adding a few different styles of borders, exploring the available parameters there of like, do you want it to be dashed? Do you want it to be solid? Do you want it to be bold? What are the line thicknesses and things like that? And then he ends with cell backgrounds, and you learn to adjust individual cell backgrounds by exploring not only the fill types, repeating types of patterns that you may want to do. So if you think of like a repeating lines, so every row looks different from another, which can help you if you're looking through very long spreadsheets to kind of keep your place maybe. So yeah, I think it's a great introduction to these topics. It's a fairly short introduction to them. And if you're interested in digging deeper into the OpenPyXL library, I would really suggest the documentation. I think it's a really good resource. And then we also have some other additional resources on Real Python, which I'll include as additional links. So thanks, Mike.
Mike actually posted a follow-up as well. So there's a companion article that talks about things like images. And he's...
Oh, this is in OpenPyXL also?
Yes. Yeah. It's essentially a follow-up to the font and styling ones before. So it was like a week later in his newsletter. And he's recently posted a Udemy course on Excel and Python as well. So there's a lot of great content there if you happen to be interacting with Excel in your Python world.
All right. Thanks, Chris. So what do you got next for us?
My next one is called Use Weird Tests to Capture Tacit Knowledge, and it's by Justin Duke. Quick tangent, tacit is a weird word. It just doesn't look right. Anyway, the article is about the idea of using unit tests for structural compliance as well as typical testing. Say, for example, you're adding a new module to a Django project, which they call apps, but that's just confusing. So if you wanted to get it to work, you have to put it in the settings file. You've got to register it. But to get other tools to work, you might also need to put it in, say, a PyTest configuration file, or maybe your PyProject TOML file, or a metrics configuration file. And so when you're dealing with this situation, a common practice is to write a script that does this. So you use the script to create a new module, but now you've got the problem of having to remember to use that script instead of the standard way. So Justin's recommendation is to shift this process to the left and make it part of your testing. So you add a test that checks for all the apps defined in the settings file and then goes through them and tests whether or not they appear in the other places that they're supposed to. So you can still have your creation script if you want, but if you or another member of your team forgets to use the creation script, the test will catch the slip up. It's an interesting idea. It's sort of expanding testing from being about your business logic to a wider net of something that exercises all of your code base. The other side effect of this is it's self-documenting. Writing something in the code documentation that says to other coders or to yourself in the future, hey, don't forget to do X when you do Y, is easy enough to miss or forget. But having it as a test means even if you do miss it, it gets caught. So this is some good advice from Justin Duke.
Nice. All right. I think that takes us into projects. We have 3 projects to dig into. Bartosz, did you want to go first on this?
Sure. So the project that I wanted to bring up here is called Whenever, which I believe was briefly touched upon on the podcast at some point in the past. It is a relatively new library for working with dates and times in Python, which takes a completely new approach, which was inspired by some proven libraries from other programming languages, like nodatime in .NET, which I believe is a clone of Java's yodatime library. This Whenever a library also takes advantage of Python's type hinting to ensure correctness as you type the code rather than rely on runtime checks, which may be too late. And the library was first released a few months ago, so it's likely not production ready yet since the API is maturing and subject to change. But the project follows semantic versioning, and there's a clear roadmap in the documentation. Interestingly, they plan to rewrite the core parts in Rust for better performance in a future release, which almost sounds like a pattern these days.
Yes.
As of now, Whenever is implemented in pure Python and comes without any third-party dependencies of its own, which means it's fairly lightweight. But you might be wondering, why do we need yet another datetime library? After all, there are already a bunch of popular third-party libraries to choose from, like Pendulum or Python Dateutil, which address some of the shortcomings of Python's datetime package. Well, it turns out that dealing with dates and times correctly is a notoriously difficult problem. And even those existing libraries have their own surprising quirks and pitfalls. You basically have to think about time zones, leap years, daylight saving time changes, different calendars, date formats, time conversions, and even sometimes government legislation. There have been some discussions about dropping the daylight saving time changes in the European Union not that long ago, for instance. And as a result, the software has to constantly keep up with all those updates. On top of that, those existing Python libraries make it almost too easy to essentially shoot yourself in the foot if you're not careful. A very common mistake is mixing time zone aware with naive datetimes, which are those without a time zone, yet both are represented by the same data type in Python. So once you have a naive datetime, you may mean UTC or local time. Also, how do you define a time zone? Some formats use UTC offsets, others use IANA codes, and the list goes on. So you can confuse time instance with time durations, for example. And in contrast to these existing libraries, the API of Whenever is designed from the ground up to minimize such risks. The library provides explicit types for different use cases and can handle daylight saving times and also provides convenient time conversion routines. Finally, it has a pretty decent documentation with some nice examples. So I'm really looking forward to seeing how it develops and whether the community will adopt it.
Yeah, we dug pretty deep into date time pitfalls, and we'll include a link to that article that covers some of those common issues that people don't realize. And then I think the article that you were discussing, Chris, was that different libraries handle these problems differently and they all have their own possible side effects.
Yeah, none of them are comprehensive is really what it comes down to. Whichever one you pick, you're going to run into some problem. So part of what you're trying to do is figure out how you're using the date times and pick the library that solves the problem easiest for the problems you are going to run into.
Yeah.
And that includes the standard built-in Python ones, which is why there's so many third-party libraries out there as well.
I think that's such a wild thing. Is there a repository that has all of the information about the global time information?
I believe there is. Yeah, I believe there is. It's called the Olson database, I think. It's like a common database that encapsulates all the different time zones and tracks the changes that different countries introduce.
I would think most of it's inside of the zone info file as well, which got introduced in Python 3.9 or 3.10?
I believe the Olson database is language agnostic, and the time zone must be based on that.
Pulling it in. Okay, cool. Awesome.
And for those who get up in arms about we should get rid of daylight savings times or not, and we're having similar conversations again here in North America as well, Bartosz, but we'll post a link to something that popped up in Ars Technica just after the time change here, talking about the actual science behind whether or not we should change, and the fact that most people say if they're going to go, we should go DST permanently, and then the scientists are actually like, every time we've attempted that, it's failed, and this is why. So if you're interested in a deep dive as to whether or not we should get rid of it, and if we do how, this article is kind of interesting.
All right, yeah. So lots of additional links this week. That's great. So my project, I'm actually very fascinated by this one. It's called hyperdiv. The subtitle is Build Reactive Web UIs in Python. And so I thought, okay, so this is going to be pretty JavaScript heavy. And no, actually hyperdiv hides almost all of that behind you. It's entirely Python. But under the hood, it's got all this stuff built into it. I'll read their disclaimer. It's a framework for rapidly developing reactive browser UI apps in Python with built-in components, terse, immediate mode, syntax, and minimal tool boilerplate. So their goal is here one language to learn and use for building web stuff, which is Python. Underneath the hood, they have leveraged a tool I wasn't familiar with called Shoelace, which is a library of web components, which looks like it has lots of really nice stuff built into it. It's kind of where the reactiveness of the library is sort of hiding, but that's just brought in and you don't have to worry about learning Shoelace. It's ready to go inside there. It also uses something called, I'm thinking it's pronounced Mistune, which is a fast Python markdown parser with renderers and plugins. And it's got what they call sane common mark rules. That also leverages something called pigments that we've talked about from time to time on the show. And then another library, and this is where I got really fascinated with this, was like, okay, yeah, I've seen lots of markdown tools, and I've seen lots of sort of tools to allow you to create, different areas of web layout stuff. But it also incorporates Chart.js, which is a really great JavaScript charting library for modern web components. And it's really playful. It looks very, very pretty. It's also very engaging. So as you change things or a user interacts with it, like just even hover states, it's got really great animations. When you put the data into it, it sort of snaps into place, which I think is really fun. And so if you have different states of a chart, it'll animate between them. And that sort of reactive stuff is really kind of neat. They call this library Fixed.js. Hyperdiv's JavaScript frontend is a piece of fixed generic boilerplate. It's similar in ways to libraries that we've talked about off and on of HTMX. So again, you're not digging into the JavaScript part of it. You're just able to sort of leverage it and use it, which is really kind of nice. The browser only contains the currently rendered state of the app. The JavaScript front end never receives unrendered data, so it keeps it from leaking out your data. They have a great doc site tool in it as an example app. I think it's really nicely done. It not only opens up the sections and you can run it on local, and it has a really nice section about how to deploy, which I think is nice that in the docs it includes something like that. Often I feel like you're going out to like a tutorial or other places to learn how to do that sort of stuff. And here it talks about setting it up locally, the complexity of things. If you like, okay, maybe you need to set up it with Nginx and TLS, and you want to make sure that it's using something like certbot. It's got all those kind of details right there in the docs, which I thought was really handy. I'm definitely going to be playing with this library more. I'm very excited about it. It's a very early version of it currently. You can learn more at hyperdiv.io, and then I'll also include the link to the GitHub for it. So, and you can just install it from pip. So I'm very interested in this library. I think it's going to be a pretty fun one to watch. All right, Christopher, what's yours?
Our final project this week is called Django-tui, and it's by Andrzej Pechar. And it's a simple concept, but a useful one. Django has a command line mechanism called management commands, which are used to do things like create a new project, add an app, create a super user account, and manage the database. These are activities that you don't want just anyone to do, so they're not necessarily built into your site, but you can perform the actions from the project's directory, so you're actually on your server kind of thing. Django ships with a whole bunch of these management commands, and in fact, you can write your own. And most of them have a whole bunch of options, and that's where Django-tui comes in. You run the TUI, which itself is a management command, and you get a text-based UI with a listing of all the installed management commands on the left-hand side. And when you highlight one of them, you get the information about the command and its options on the right-hand side. Options that are Booleans become checkboxes, and those that take arguments have input fields. So you can then modify the options for a command, and the tool builds the actual shell code that needs to be called. You then click or hit Control-R, and it runs the command for you. So it's a neat little tool. And another good example of what you can do with a TUI. Andrzej's GitHub profile says he writes code and surfs waves, which makes me wonder how he feels about achieving the little pull shark GitHub badge. But if you muck around with Django commands, then this project's worth taking a look at.
Yay, more TUIs.
Sounds interesting. Do you happen to know if it was written using the textual framework?
Let me double check. I'm 90% sure it is, but let me double check.
Have you been playing around with rich and textual, Bartosz?
I tried. I was a little bit intimidated by textual, which seems to be replicating a lot of the things that you would expect on the front end. So it uses CSS to style the components, and it uses a lot of the patterns that you would use on the front end, which, yeah, I guess if you're a front end developer, then using it on the back end suddenly is easy enough.
Yeah. Yeah, it definitely does use textual. I was 99% sure, but I wanted to double check before I said yes.
All right. Well, Bartosz, thanks for coming on the show this week.
Yeah, it was good to have you.
Thanks for having me. Yeah, it's been a pleasure.
And Christopher, thanks for bringing all these PyCoders articles and projects this week.
Always fun. See you in a couple weeks.
All right. Talk to you soon. And thanks again to Posit. Posit Connect helps make deployment the easiest step in your analytics workflows. Learn more about Posit Connect and try it for free for 3 months at pos.it/realpython. I want to thank our guests this week, Bartosz Zaczyński and Christopher Trudeau, for coming back on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.